Hello friends, this is Durga again from Technology Mentor / ITversity, and as part of MapReduce application development using Hadoop based APIs, we have started with simple MapReduce application for record count, and then we have written full lifecycle implementation for the average stock volume per month, and then we started developing another MapReduce application to get top 3 stocks by volume, which includes filtering, partitioning, custom comparators, so that we sort and group in such a way that we can use the reducer to actually get the ranking without complex coding as part of the reducer. So before starting developing the reducer, let me show you why we should have to use this grouping and sort comparator. Okay, if you run this program with the number of reduced tasks as 0, okay, and if you try run configurations arguments 0 run, so this you will see how the data is in the file when we actually set the number of reduced tasks to 0, how the data will be processed by mapper before passing it to the reducer. We will get both the keys, which is our long pair primitive, which stores the date and also the volume, and then the record also. So for mapper, if you go here, the output key is nothing but a trade date, which is in numeric format, and the volume, and then value is nothing but record. So the program is executed. If you go to output 00, you can see one file, and this is how data is being written out of the mapper. And if you go to the end, the data can be is not sorted at all, because when we say mappers to be reducers to be 0, there will not be any partitioning and all happening on the map side. So the way it receives the data, it will emit to the file. Now let us say our number of reducers are 4, and if you don't have grouping and sort comparators, or if you don't have your grouping and sort comparator, even if you have the partitioner, and the partitioner only partitions on the first field, which is the date in this case, still when it comes to reducer, the key for the reducer input will be the composite key, which is date as well as the volume. So for each combination of date and volume, the reducer will be invoked. And if you have to get the top 3 stocks for each date, because the key is both date and volume, it will be nightmare to get that logic running. So that is not practical without using grouping comparator and sort comparator. Let me show you what I'm talking about. Okay, I have commented out these 2 lines, and let me print both. For reducer, I'm trying to print both the key and value. Okay, and let me compile this one into a jar file and run on the cluster. Okay, so now I have to do SCP. I am copying into the cluster, and now I am connecting to the cluster. Okay, and now I am running. Let me delete the files, and now I am running the program. Okay, let me name it as output 00. So in this case, our reducers are 4, and we are using the first key long partitioner, and see how the data will be represented and how many reducer input groups are. Reducer input groups is the very important metric which you need to understand here. Okay, I'm hitting enter. It will take a while, and then I will show you the counters and also the data in the files that are stored in the directory output 00. So the program is executed, and if you look at the counters, especially the MapReduce framework, we have 1.5 million input records, and as we are not filtering anything as part of the mapper, we have the same number of output records, and we are not using combiner, and combiners does not apply here. Combiners only apply for the aggregation framework. In our case, we are not aggregating the data. Okay. Then the reduce input groups, you can see around 1,119,892. Okay, because there are some conflicts between the date and the volume. So there can be multiple stocks with the same volume within a given day. Because of those conflicts, there can be lesser number of input groups, but the reducer will be invoked 1,119,892, and the key will be the combination of date and volume, and the value will be either one record or more records if there are conflicts. Okay, so now let us review the data. For that, I am getting output 00 directly to the local file system so that I can review it easily, and now it is copied, and now you can see that there are 4 files, and you can actually cat these into part consolidated, and then you can view the consolidated file, and you can see that the key is date and volume. And if you look at the beginning, there is a conflict for 2012 January 2nd. All the stocks are not traded at all on that day, so there is 0 for all the stocks. That's why the number of keys need not be equal to number of records in this case. But for each of this unique key combination of date and volume, if there are duplicates in the volumes, there will be array of such kind of records, and we can process those records as an array holding that holding this composite key of date and volume. In this case, our requirement is to get the top 3 stocks. If you hold both the date and volume as the input key, then you can only get records with matching date and volume. And between the reducer calls, you have to manage the data to get the top 3 stocks, and it is completely impractical to develop that complex logic. You have to build the hash map, store for each and every day into the hash map, and then process through the hash map before writing it to the HDFS, which is completely impractical. And even if you are super smart to implement that logic, you should not do that. Not only because it is complex, performance wise also it is very bad. So now, and also you need to take care of sorting. In this case, by default data is sorted in ascending order, and we want to change the behavior. That's where sorting comparator comes into picture. And even if you have the sorting comparator which sorts in descending order by volume within a given day, still the number of reducer calls will be around 1.119 million, and you cannot actually get the top 3 stocks easily. Your logic might become a little bit simpler, but still you have to maintain a data structure which is alive across multiple reduce calls, and you can lead into many issues such as out of memory, slowness in the performance, etc. For that reason, we have to not only use the sorting comparator, we also have to use the grouping comparator, wherein even though you have a composite key, we want to invoke the reducer only for the leading column in the composite key, which is date in this case. Okay, now let me compile it. Still we are using the default reducer. Run as maven install, and then come out of it, exit scp, and then ssh, and then run our Hadoop jar command with 1 as the output 01 as the output path, and hit enter. It will take again a couple of minutes, and I will show you the counters and results once it is run. And it is successful, and you can see that input groups are only 522 because there are only 522 days in the span of 2 years on which trading happened out of 730 days, so which makes sense in this case. And now let us copy the file, copy all the files to local file system so that we can review them easily. Okay, now you have this file which is consolidated, and you can see that for each day data is in descending order, and the counters is proving that the reducer will be invoked only once per day, not for once per each day and volume. So even though that data seems to be displayed similarly, that's because of the default reducer behavior. It will hold the key, and for each value in the array it will print the key and value. So if you have 100,000 records for a key, there will be 100,000 records which will be printed by the default reducer, which will have both key and value. That's why you have the key and value for each and every record, but the difference is it's in descending order. And also we have seen that our number of reduce input groups have come down to 522. So the reduce function is only invoked 522 times, unlike 1.1 million times like earlier. Okay, I am going to the first record of 2013-12-31. Okay, let me do this. 2013-12-31. Okay, now the data is in descending order, and for each date. So the desired outcome is to print only the first 3 records in this data. So we have to implement reducer logic in such a way that only the first 3 records are displayed. So let's start developing the reducer. I'm right clicking on the package, new package, and the name, I have to give the class name, new class, and the class name is top 3 stocks by volume per day reducer .java. No need of extension here. And then I have to extend reducer, and it is of type, in this case I don't want to print the key. I will start with printing the key, then I can remove it. So the key is of type long pair primitive, and value is of type text. Okay, I have to import these packages or classes. Okay, I have to give the output key and output value also. So output key also long pair primitive and text. Okay, now I have to extend public void reduce, and I have to give long pair primitive input key iterable of type text and records, and then context, and I have to throw IO exception and interrupted exception. Okay, now I have to implement that logic. So for that, I'm not doing a lot of exception handling and addressing the conflicts and all those things. I am trying to write a very simple MapReduce program. It's a very simple program to implement this reduce logic. So the loop is of type text because we have iterable of type text and record and records. Okay, and then I want to write context dot write. I want to give the input key and the record. Okay, so now what will happen? All the records will be displayed similar to what we are seeing there, but we want to get only the top 3 stocks. For that, we have to have a counter here, int cnt equal to 0, and for each and every reduce function call, this count has to be reset, so it has to be local variable inside the reduce function, and we have to increment the count, and we have to write only if count is less than or equal to 2. Only if the top 3 records we need to write, otherwise we should not write. Okay, so that's why we have to keep this, else we have to break. Okay, so that we come out of the loop and it will come out of the program. Very simple reduce logic, nothing fancy, and the actual ranking algorithm has become so simpler because of the implementation of the grouping comparator and sorting comparator. Now let us test this. I am building okay, I have to reset, I have to go to driver, and in this I have to use this reducer rather than what we are using right now, which is the default one. Okay, and then go to pom.xml, run as maven install. Why I am running on the cluster is I just want to show you the counters and make sure how you can validate the counters also for unit testing or sanity checks, and then you can also get data and validate the data. If I run locally, I am not getting the counters. Probably I might have to extend logging somewhere in my project. So I am coming out of this cluster and then SCPing the jar file to the cluster, and then I am doing SSH to the cluster, and now I am running Hadoop jar command again using output 0 to add the output directory. It will just take a minute or two and we will review the output. So now it is run, and you can see that reducer is invoked only 522 times and reduce output is only 1566 records, whereas in the previous program reduce output is around 1.5 million. So sanity check is looking fruitful, because for 522 records we need to get top 3 records, which means 522 into 3, which is 1566. Okay, so it seems to be good. I am getting all the data into this directory locally, and then I am actually creating the consolidated file, and you can see that on each and every day we got top 3 records. So on 2012 January 2nd there is no trading at all on any of the stocks. That's why you see the top 3 with zeros. We are not handling the conflicts and all those things. But for 2012 January 3rd, Bank of America is most traded stock with 240 million, and then other 2 stocks, GE and I don't know what is C, is around 58 million and 58 million approximately. So it is the case with all the days. We got it in we got top 3 stocks for each and every day, and the data is also in sorted order. The reason why data is sorted is because we are using this first key long key partitioner, first key long pair partitioner, which is in partitioners, and there we have simulated the range partitioning here. If that is not the case, then it will be randomly going into different files. Okay, so that being said, you might not want to see this key, you just want to see the record of all the top 3. So it's very easy to change that. What you have to do is you need to go to the reducer. If you go to the types which we have discussed earlier, key and value types, so if you look at these key and value types, there is a type called NullWritable. So if you want to So when you actually write it into HDFS or pass out of mapper, you always have to pass key and value out of the mapper as output and also out of the reducer as output to HDFS. Both key and value are mandatory for typical MapReduce programming. And in certain cases, if you don't want to write key or value, what you have to do is you have to fill that using this NullWritable object. So what does that mean is when you use NullWritable, nothing will be written to the HDFS or passed out as the output key or output value if the key or value are NullWritables. So let me show you how you can take care of this. In this case, we don't want to write the reducer output key, so we have to define it as NullWritable here, and then we have to import this, and then here you have to say NullWritable dot get, okay, and then you have to go to the driver, and in the driver also you need to say that output key class is NullWritable, not whatever it is before, long pair primitive. So here I have to import this one. Now if you use this and pom.xml run as maven install, I need to do SCP Hadoop and then SSH. Hadoop is the password, and then I'm running the program. So you can see that it is 522 input groups and output records are 1566, which is in line with the previous one. And now let us get it to the now let us get into the new directory. Output 032 local, and then I'm going into the new directory which is created because of that Hadoop fs-get command, and then I want to cat into consolidated file, and then I want to view that consolidated file, and you can see that there is no key now. You only have the values which are the records which we sourced from the source. Only difference is source have data for all the records randomly ordered for each day. In this case, we got only the top 3 records for each day by volume. Okay. So that being said, that's it for this video. In the next video, we will continue the same program and we will try to use something called multiple output formats. And there are so many hidden things in that. You can do the global sorting even using multiple output format. And also you can simulate the partitioning of your data. So far, if you look at the Hadoop FS output directories which are being generated, under output you see 4 files with part minus r 00000000123 depending upon the number of reducers that are defined. So there is no business logic in these directory names. So we can actually have some business logic in that, simulating the partitioning of the data, and it's very important concept which we will be seeing as part of the next video, playing with the multiple output formats and how we can actually have meaningful names as part of the directories, and it will come handy in many ways to the downstream applications. So that being said, I hope you are enjoying the content so far on my channel. If you have not subscribed it, please do so. If you like a particular video, please click on the like button, and if you want to provide any comments or ask any technical question related to a particular video, please do so using the comment section of the video. That being said, thank you, bye.